Okay, on page 476, we're going to have to identify the transformation. We're going to have to produce a graph. We're going to have to graph it on the same coordinate plane. We're going to have to apply the transformations, find the asymptotes, use the reference points, and state the domain and range using inequalities, set notation, and interval notation. So there's going to be a lot of answers on one problem. Okay? So, if you remember before, we used reference points on all of our problems when we were making a table that looked like that. Remember? Okay, these are your two reference points that you're going to use on all of your rationals. Those two right there. Okay, first of all, let's state what this equation does. What did the parameters do to this equation? We know that it reflects across the x-axis. So write that down. We also know that it does what? It has a vertical compression by 1/2 or 0.5. What else do we know? It translates where? Left 1 unit. Or 1 unit left.
So even though it's moving around, it's still never going to touch 0.
In this case, it's not going to be zeros it's not going to touch. It's going to be something else it's not going to touch.
So it's going to move, but there's still going to be a line that it's, it's going to
right.
go. Okay.
It's still going to have asymptotes. It's still going to have a vertical and a horizontal asymptote, but they'll be different. They won't be at 0. Okay? And I'm going to show you in just a second how to find those. All right, what else does this do?
3 units to the
Where am I going?
Translates 3 units down.
3 units down. All right, so we know what it does. All right, let me show you how to get the horizontal. Here you go, Truman. Horizontal asymptote. To find the horizontal asymptote, you set your denominator equal to 0. So my denominator is x plus 1. So when I set that equal to 0, it will give me x equals -1. That is my horizontal. I just lied. That is my vertical. I'm sorry. Vertical asymptote. So at -1, I'm going to have a dotted line at -1. That is going to be a vertical asymptote. My graph will never touch that. Horizontal asymptote. Is going to be whatever your k is. So this right here is my k, -3. So my horizontal asymptote would be y equals -3. So I go down 1, 2, 3, and I draw a horizontal dotted line at -3. Okay, let's go back up here to our table. What are we doing to our x? Now, we're talking about just the x, just the part in parentheses. What are we doing to just the x? Remember, it's opposite. X minus 1. So I'm looking at just the part in the parentheses right here. It's always, everything in the parentheses is going to be opposite. So what am I doing to the x? It says plus 1, but I'm always doing opposite, so I would minus 1. What am I doing to the y? So we pretend like this is the y. What am I doing to it?
Negative 0.5.
Negative 0.5 y
Minus 3.
minus 3. Negative 0.5 y minus 3. Now, here's my reference points. That should be a negative.
Oh.
Sorry. I put those reference points into each of those. So when I put a negative 1 in for x, negative 1 minus 1 is
Negative 2.
negative 2. Then I put this one in for x. 1 minus 1 is 0. Now I'm going to put the y values in. Negative 1 in for y. Negative 0.5 times negative 1. If I put a negative 1 right there, is going to be a positive 0.5 minus 3 would be
Negative 2.5.
negative 2.5. Then I'm going to put a positive 1 in there. Positive 1 times negative 0.5 is negative 0.5. Minus 3 is negative 3.5. Those are our new points. Now I'm going to plot them. Start at our origin 0, 0, go over negative 2 and down negative 2.5, which would be right there. Somewhere along there. Now, notice where this point is. Here's a vertical asymptote. Here is a horizontal asymptote, and that point is up there in that corner. Which means when you draw your graph, it's going to go up close to that asymptote and never touch, and it's going to go down close to that asymptote and never touch. Okay? But notice that asymptote is not 0. Okay? It's negative 3. Now let's plot the other point. 0, negative 3.5. Right there. So it's going to get real close to that asymptote right there. Real close to that asymptote right there. And never touch. Questions so far? Now we have to do the domain and the range. Domain. We're talking about left and right. We're going to do the inequality first. So what would my inequality be?
X is less than negative 1.
X is less than negative 1, or X is greater than negative 1. Right? Set notation.
Oh, we have to do it in all of them?
Yes, sir. Braces X such that X
It's not equal to negative
X such that X is not equal to negative 1 braces. Interval notation. Parentheses what? Negative infinity, negative 1, union, negative 1, positive infinity. Any questions on the domain? Range. Inequality first. How would I write it?
Y is greater than
Let's start out less than.
But y is less than -3.
Y is less than -3, or y is greater than -3. Set notation. Braces y such that y does not equal -3. Interval notation. -infinity to -3. Union. -3 to positive infinity. None of that's in brackets. Any questions?